supposed to do the exercises, but it's really hard to get them to actually do that. I agree, we should totally do that, but they often end up just feeling really shy and not wanting to talk to each other. Or they're trying to concentrate on the problem. They don't want to also try to talk to someone else.
Right.
So I usually just delay them until they start talking.
Hello, Internet. My name's Andrew. How do you make this share screens instead of a picture of my own head? Do you know how to make it?
It's one of those buttons.
Oh, okay.
Oh, no, it's the green thing on the left.
Green thing on the left. Oh, I knew that. I asked the question and I knew it. Okay, there we go. Start screen share. Great. Oh, into infinite to ever. And that's a good sign. You are screen sharing. Start, present to everyone. All right, and now I get a link to this.
And throw it in the issue.
YouTube. Do I video embed or events page or like the YouTube?
The YouTube link.
The YouTube link. All right. It's going to blanket me. I'm sitting here. Oh, have you guys been following the Twitter controversy or whatever? I'll tell you. We'll talk about it after. Okay, here we go. And
you can't just drop that and then back away from it.
Oh, the guy Oliver Keynes from the Wikimedia Foundation recently he submitted a bug request to our core, arguing that a line, it was a function name buried somewhere very deep in our source was inappropriately named, and he wanted to change it, and then that generated, controversy. And a lot of people were like, yeah, whatever, let's change the name. Well, like our users, but the president of the foundation found the whole thing, his words were shit disturbing, and shut down the entire discussion. So it was very depressing. I know, it makes me feel for my community. Link to.
He's not saying like I'm not developing that, right?
That's right. Yep.
He got banned from like the band, whatever.
And they banned him for making a suggestion.
Yeah.
Boo.
That's
The record show internet that the UBC Art Study Group is against the banning of Oliver Keynes from the Bugzilla page for our core team. All right, enough silliness. Thank you, everyone, for coming. I want to talk to you, but what? You can't see my screen. I knew that. Now the internet can see it, but you guys in the room here can't see it.
no.
Oh, dang. All right. We're going to learn about assertions.
Oh, you're starting.
Sorry.
That's okay.
No. It has to warm up.
Okay, the last two things about the workshop. Joey was saying that maybe they could collaborate on writing different parts of a function. And then...
Like over Git or something?
No, well, like...
Not that complicated.
Not that
working
complicated.
together.
It's just like,
Okay.
having like a function that has like 2 or 3 chunks or something and have them each work in each chunk and then put it together or something.
Great idea.
And then, yeah, she said that have a bit of time over lunch for learners to ask questions that are specific to their own work. And then maybe more personal one-on-one for learners with the specific questions. Just some thoughts. But yeah.
Those are all great ideas, and most of them are like supposed to happen. It's just harder to pull them off than it sounds.
I see.
The last one isn't actually that hard. We just need to make sure people understand that we're available to talk over lunch and stuff. That we should easily rectify.
Yes, that should happen.
Well, they all should happen, but that one I think.
Okay.
Okay, assertions.
Assertions, let's do it. Is that a good color scheme for everyone? All right. Hi, I'm Andrew. So I want to talk to you. I want to talk to you today about an R package that I first learned about when it was featured in our community call back in October. And the purpose of this package is to fail early, fail often when dealing with data sets. So the context where I see a scientist using a tool like this is if you're dealing with a lot of data, potentially coming from collaborators, maybe you're doing a meta-analysis and a bunch of your friends are sending you data sets, or you have an undergraduate who is working with collecting your data and you want to make sure that his or her work is following some logical pattern, or maybe you're getting data off the internet, you're scraping a web page or something. There's a lot of them, thousands of text files. You want to make sure that they sort of make sense. So I want to start, as usual, in lessons, perhaps with Gapminder. We're going to load in this Gapminder data set. If you don't have Gapminder already, you can install it with install.packages, Gapminder. I won't do that, but I will just load the thing and look at the top of it. Most of us are probably familiar with this data set by now. Gapminder has 6 columns, 1 for country and 1 for continent, and then 4 numeric columns: year, life expectancy, population, and GDP per capita in that year, every 5 years since 52 up until 2007. All right. So we're looking at this data set. What do we know about this data? I just told you the names of it, the names of the different columns. But what should each of these columns look like? What about country? What should the data that comes in the country column be?
A factor?
It should be a word. Yep, factors has sort of an R, but it should be a word, right? And specifically, there should be words of countries, real country names, yes, and all spelt the same way. All right, same thing for continents. How about how about year? I totally passed over year. Year. Exactly. It has to be an integer, and it also has to be positive. You can't have a negative one either.
Probably shouldn't be from the future.
It probably shouldn't be from the future. It should also be less than 2016. I like that. I hadn't got that written down. Likewise, life expectancy, population, and GDP.
Population also shouldn't be. It should be an integer.
Pop is also an integer. And life expectancy and GDP, positive real numbers, not necessarily integers. All right, so that is just coarsely what each column could be. We could probably go on making more and more things about how variable each column should be, for example. But let's start with that. If I was going to use just base R to do this sort of thing, I might write a statement like this. Is everyone familiar with the base function stop if not? See this in a lot of R functions. So if I give this a logical test, just to recap, I'll go up here to line 6 and just recap some simple logical testing. I can say 3 is 3 equal to 4. That's false. It'll stop if not, expects you to say something that's true, and if it isn't true, it'll stop. So you could say 3 equal to 4 in here, run the line, and it stops, saying that that statement is not true. And this is usually used inside of functions to stop their execution if something's not the case. For example, if the user hasn't given a certain argument. But we could, if we wanted to, sort of jury-rig it to check our data set. We could say something like, stop if not, and then we'll just look at one of the columns in Gapminder, say Gapminder, $, and R should just open us out, giving us a completion list. I will choose life expectancy and say that it must be greater than 0. Nothing happened, which means that condition is true, which means I can carry on with my life. So far, so good. What might a drawback to this approach be? Well, first of all, it took a lot of typing to get it, and it's not super clear to read. Second of all, stop if not, as evinced just now when I asked a room full of people who credible R programmers, if they've ever used it, they haven't. So it's a fairly obscure function in the first place. Second of all, this doesn't really combine very nicely. Suppose I wanted to test more than one condition. I could write out this entire statement again. I'll just copy it and add it for population, say instead. Possible to do, a bit laborious. I could see a whole R script stacked with lines like this, where only one thing is varying in each line. And if I were to try and chain it, I might try and do something really awkward. Gapminder. The pipe command. The pipe command seems like a logical construct for this kind of process because we really are sequentially verifying qualities in our data set. So just as a recap, the pipe command moves whatever is on the left to the first argument on the right. So here I could write something like this. Use curly braces, stop if not. In pipelines using this pipe from dplyr or mgriddr, the dot represents the data set or whatever has been passed in. So I'll take the data set and then maybe take life b greater than 0. And I can carry on and write another one. On that line. All right. That also runs without producing an error and gives me confidence that, sure enough, life expectancy and population are greater than 0. But this is already sort of getting out of hand. I could carry on like this with lots of dots and dollar signs, but surely there must be an easier way of doing this. Sorter tries to make this more convenient by presenting a few canned functions we can use in the same way. The simplest one is called verify. And it does something much like what we're doing here. Oh, before we use these functions, obviously, we have to load it. There we go. If you don't have this package, it can be installed from cran. Install packages, ASSERT, followed by an R. You can also install the dev branch off of GitHub. But I will put a link to that up in the issue afterwards. Or even I can put all these notes on the study group website, yes? All right. So let's try playing with verify. Verify does something very similar to stop if not. It evaluates a logical condition, except it's smart enough to know it's going to get a data frame, so we don't have to do this business here of selecting the column of the data frame that we want. So let's try it out. Starting a game with Gapminder and piping it into verify. Everyone with me? Does everyone have this package? Yes? Great. All right, I'm going to verify. All right, one simple thing I can do is check, for example, the number of rows in the entire data set. Using the dot once again to represent Gapminder that's being piped in, I give it 1704, which happens to be the number of rows in Gapminder. If I run this whole expression, you can see I don't get just true or false back, or silence in the case of stop if not. I get the entire data set back, which is great. That means I can carry on piping it straight again into another condition to test. So we know the Gapminder has 1,704 rows. How many columns does it have? Or should it have?
6.
Yes, exactly. Verify and call. That seemed to have worked as well because it printed up the whole data set. Now let's use it to test one of the same, one of those columns for a certain condition. Bill pointed out earlier that continent and country should both be factors. So let's check continent to see that it is in fact a factor with the handy base function is factor, which returns true if that vector is a factor. This is just a simple logical test. If it's true, verify will keep going on with the data set. Looks great. We can even test some more details about this factor. For example, verify how many levels, how many continents are there in the world? How many levels, in other words, does this vector have?
6 or 5?
I suppose it does depend on how you count. Gapminder recognizes 5. Ignoring the silly pipeline, a better question. more practical one is how shall I count how many unique values of continent are in Gapminder? I can get the Gapminder $ continent. Great. I don't know how many levels are there. Levels works. Typing levels, I can get the values, or unique would also work. But if I want to know the number 5, I can use length, yes? And length will tell me that that vector is 5 long. So there's 5 continents in Gapminder. So I can just copy this. Now that I've got this, I can put it into verify and say the length of the continent levels should be 5. In other words, there should be 5 unique continents in this data set. And so on and so on. And you can keep writing this down all the way as far as you want to check every condition of the larger data set. Great. This is already a marked improvement over trying to do something with base functions. It does, however, have the drawback that we have to keep naming the variable that we want to investigate. And each one of these contents of the brackets must evaluate to a single true or false, which kind of constrains us. Is there an easier way, for example, to say, look, the levels of the continent, there should be 5 of them, and they must be one of Africa, America, and so on, Europe, Oceania, and it must be spelt this way with this capitalization. The reason why verify can't quite get us there is verify evaluates things on the whole data set. So verify is working with Gapminder, the big gigantic square. We want to work with each individual column name. So asserter ships with another function called assert that we can use to do that sort of calculation. Let's play with assert a little bit. We'll start in the same way, Gapminder. And this time we'll assert. I'm just going to pause here and look at the helpful tip that RStudio was suggesting for me. The first argument is data, like usual. Gapminder will get piped in. Then the second thing is this thing called a predicate function. I have this bit here where I try to define a predicate function. Programmers in the room, feel free to chime in. But I have here as a crude definition, a predicate function is a function that gives you a true or false for every element in a vector. So it's a little function of x, where x is the first thing, and then the second thing, and then the third thing. And whatever is going on, it's going to tell you true or false. And it's not like a function like this, which is where the vector is one of the arguments, and it's all compared to a single number. Instead, it would be as if you replaced this over here with x, and then ran that function down the entire Gapminder column. So there are some handy predicate functions in base R that we could use. We're just going to use a few from asserter to start with. So instead of saying, for example, that population is greater than 0, we can use this handy asserter thing called within bounds. And then within bounds, we tell it what range the data should fall in. So if we think that that population should be a positive number, we can say that it must be greater than 0. And it must be less than infinity. Nice wide range. And then we use a comma, and we just simply name the variable that we have that we want to check. This is already really interesting because, as you can see, I didn't have to quote this variable name, and I didn't have to tell it to look inside Gapminder for it. It already knew. If you've done a lot of data manipulation in R, you might recognize this kind of syntax as being very similar to select, where you simply name in dplyr. And in fact, assert uses the same thing as select in dplyr, the same form of what's called non-standard evaluation. It lets us pass in column names and not quote them and not say where to look for them. The function knows to try and find them inside of Gapminder. So That means we can use the same syntax that you can read about in the dplyr vignette for selecting columns. We could, for example, say, let's look at the head of Gapminder again. Instead of saying, please check that for positive values in year, in life expectancy, in population, and GDP, we could say year, GDP, meaning everything between year and GDP. Check all 4 columns. I'll go up here and modify this function. Year, GDP per cap. There, it just checked all 4 of those columns. Any questions so far? What do you think of that? I'm gonna pop over to the internet website and see if are there people in here? That's really distressed. I find that quite distressing. It's just a tiny bit uncomfortable. Would people? Oh, it's disabled. I thought I turned it on. Okay. Does anyone know if people are trying to talk to us, say, on Twitter or something?
There's 4 people on there. Did you make an Etherpad?
I did not. Let me do that.
Okay. I'll keep an eye on Twitter.
Thank you. It is working? Oh, great. That's awesome. Well, I hope it still is. Okay. If you want to make an Etherpad, we could do that. No, it's all right. Okay. Okay. Well, we'll just keep going. We're almost at some fun exercises anyway. So we have 2 other handy predicates that come along with asserter. One I really like, the one I'm most excited about, is called inset. So let's get a vector of those continents again. So I'm going to use levels, Gapminder, continent. And that'll give me back, spelling, levels. There we go. That'll give me back a character vector containing the names of all the different continents in the world. All continents. I'll put that into a little object. Now I want to see if the data in Gapminder is consistent with all of these continent levels, which it must be since I did get the vector out of there. But supposing someone's going to add a new Gapminder data set, I wanted to check it. Oh, I'm going to make an assert in set. So it's simply, I'll scroll down so can you see that? Shady doesn't always give me all the white space that my heart desires. So that's in with an underscore set. You put in the name of the vector that's holding the values that you expect to see. You type in the name of the column you're going to check, continent in this case. So this assertion will check to see that the values in here are actually found in this vector of all the allowable things. I'm really stoked about this because I'm an ecologist and I work with a lot of species data, and I want to make sure, for example, that species names are consistently spelled. So here I can have a list of the true spellings of the species names. Let's see what happens. I realized I haven't shown you this because I had to take the errors out of my lesson because we're preventing my vignette from building because they're errors. But I want to show you what happens when there's actually an error. So let's change the spelling of a continent in Gapminder. Continent. I'm just going to choose something at random and spell Atlantis, change it to Atlantis. Bad example because it is a factor and won't let me do that. That's all right.
You just change the.
Why do you want to keep doing your factor?
I suppose I could coerce it back to, that's the other solution. I could coerce it to character. That takes fewer keystrokes, so let us do that. Turning the continent into a keystroke, into a continent, and replacing that with Atlantis. And I'm going to rerun my test. Gapminder, assert in set all continents. So the cool thing about assert is that it's actually able to tell me what row of the data set, index 52 here, how many errors it found one time, and where exactly they are, 52. Let's contrast that with verify. I'll write that a little in the comment here. Contrast with verify. Do that, I'm going to mess up the life expectancy column. Just once. I'm going to take the 30th life expectancy column and multiply it by -1. Does anyone remember how I test? I'm going to type in Gapminder again. Does anyone remember how I test to see if life expectancy is positive with verify?
It's a lot
Greater than
wrong or
one?
something.
Yeah, it's
Is there a function called like is positive or something?
no, there isn't actually. No, there isn't. All the is functions in R check for types, not for values. So life expectancy greater than 0. It fails, and it tells me how many times, but because verify works on the whole data set, it doesn't tell me where the error is, which is less helpful for figuring out what to go and complain to your undergraduate about, what samples to remeasure or whatever. Okay, great. I said I threw in a tease there. I said that there are 3 handy predicates. I've only shown you 2. I've shown you in set, which we can use to find it at the levels of a character vector, or the unique values of a character vector all match one master vector. And the other one was within bounds, where you can define a lower and upper range for a variable. I would say you could use this to set what would seem to be reasonable bounds for these variables, but there is no reasonable bound to GDP. It just gets kind of crazy. But there is a reasonable bound to, say, life expectancy. Humans should live more than about 120 years on average. An average life expectancy doesn't get above 80. So that would be, you could constrain it differently. But what's the third one? The third one is called isNA, which the world has waited too long for. One of the most common things that scientists do with the data frame in R is check for the missing values and replace them with something or filter them out. This is fantastic because one of the first things we all learned is how to do this, and now it is much more automated. So this one is called assert is_NA, and we can give it the value of, we just name the function, and then we can give it column name. So in Gapminder, we could even do the whole thing. The first Gapminder column is called country, and the final one is called GDP per capita. We can just check for any NA values. Did I spell it wrong? Oh, pardon me. It's called not NA. Not NA returns true, obviously, if the value is something other than NA, presumably also other than null. And it returns false only if the value is actually NA. Which is great. This will fail only if there's missing values in the data set. There's nothing missing. Yes, Melissa?
Can you work only with like the assert functions? So, because like not NA is not a base function. And the one that we used before, insect, it's not like a base function. So can the functions that go, like the predicate functions that go into assert only be assert package functions?
Excellent question. I'm beginning to think that my teaching style is wailing away at a point until somebody asks the obvious next question. No, you can write your own. And in fact, that is the challenge that I have. So I'm going to just demonstrate how a simple case, and then we'll write our own in a challenge. So I could, for example,
Actually, I need to go.
oh, that's fine. Thank you for your excellent question.
Array map, right? It looks like an array map, right? So you'll define any function you map it onto the list of stuff.
Yes, exactly. Yeah, this is the more general programming construct is exactly this. You map these simple predicates onto whatever you want. So, for example, we could write a function to see if a word is sufficiently long. Say we know that country names or continent names must be longer than 2 characters. And if you've spelt it with less than that, you've been sloppy. So we'll define this function and then name it in an assert. That seemed to work just fine. I'm going to go up here and change this to 5, so that would fail for Asia, just to demonstrate that this is actually working. 396 times, that's the number of times that Asia occurs in the data set. It failed for every one of them. Great. We don't actually have to do the challenge, but I thought it might be fun. We were pointing out at the beginning that in Gapminder, let's just look at the head of it again. Never look at your data too many times. We were pointing out at the beginning that certain of these numbers, it's fine to be real, to be floats in computer speak, life expectancy and GDP per capita, but year and population can never be other than integer logically. So why don't we write a predicate function to distinguish those things, to confirm that year and population don't have decimal places. And the interesting thing it's interesting to note, of course, before you get started, that they're actually both stored as floats already. They're all stored as what R calls numeric. But year and population never have any decimal places.
Thank you so much.
Oh,
We're gonna work
Thank
along
you,
next week
Madeline.
to work on projects. We're gonna work along next week to work on projects. You wanna bring stuff? Work on.
yeah, feel free.
This was really fun.
Oh, I'm glad you liked it.
About not NA.
Yes,
Of all
right?
things. Have a good day.
Take care. That one's gonna blow up. All right, let's, does anybody have a possible solution?
I don't think I actually get the question.
Oh.
It's like, as you just said, they aren't integers. So I have a solution that fails 1,704 times.
You check for is integer?
Yeah.
Yeah. This is such a common problem that I feel like there must be a better solution for it. I was thinking maybe a function that's has a bit more moving parts that rounds it, for example, to an integer and then checks for difference between that value.
But what would happen if I passed something that genuinely wasn't an integer into that? Would I still round it off, get an integer, and happily march on my way?
Oh, I see what you mean.
Yes, if you're not careful, but you need to be something more careful than that.
Right. Right. Yeah, so the answer that I was thinking of might not actually. Well, alternatively, you could copy your data, write your data out to a file, read it in with different.
Put a column in
Yep.
everything.
Well, that would be really laborious. But you can you can specify the column types when you read it in. You can specify them that way and then confirm that they read in that way. All right. The capstone exercise I had in mind, or did you guys have anything?
I do not have a solution.
Okay, well, we'll have to work on that one. The capstone exercise that I had in mind, although we are running out of time, is in the issue. There's a link to a data set to the latest data that's been recorded for Gapminder. Not really. I made it up myself, and it's broken, and it's like a data error Easter egg hunt. I believe there are 5, and can you find them all? The assertions that we've written already, if properly combined, should allow you to find them. So if you click on the link in the Etherpad, it will appear.
If you read it in with like read R's, read CSVH, or a bunch of errors.
If you read with read R's, that's CS. Oh, huh. It throws a bunch of errors, does it? Why should it?
6 cars failures.
Does the data set still read in?
Retake is okay.
Let's do it as a group. Let's do this one as a group. I don't want to be causing errors.
It does read in. You just, yeah.
Oh. Will, you're so hard to fool. Using reader.
That's weird. Title column seems to be period delimited, and everything else is comma delimited.
Oh no. Worked on my machine. Maybe not that one because it'll be the one that from Reader. So when you do view, it doesn't look like this?
I don't know, I'm retabling from your URL and then just printing it. Periods.
Oh,
Commas. I don't know if that's the only problem, but that looks
Oh dear.
surprising.
Did you say you're telling you to set it to be a comma?
Yeah.
Well, you are just baffling me, little R. Okay, I think I could probably use some advice about what's the best way to get data sets to students. I thought that this link was, I thought I was so clever. Why does it work on my machine, Bill, and not yours? Let me try a read table thing.
Let me go see this raw table without loading in R. Because I can't understand how it would just decide to put periods. That seems suspicious.
It must be it must have something to do with the way it's read in.
Your file's fine.
And interestingly, Will, I used Reader, and it read into a data frame. So as you can see, it's a data table.
Yeah.
So did you get that?
Yeah, I got the data.
I tippled it.
Those errors.
Okay, it's probably already finding my.
Partly, yeah,
I think it is. That's interesting. Expected 6 columns, actual 7 columns. Oh, do you know what's? I think I must have messed up the delimiter somehow. Where's its issue with that? Row 28, 29.
Yeah, so those two.
I didn't do anything down here though. This is the same as it always was.
Look, the period.
Oh.
Uh,
Oh no, I am sorry everyone. Look at that. That's what happened. We have a frame shift error. Drat. Oh well, that's why we demo these things. Anyway, had this succeeded, and I guess I must have, when I wrote it out, it must have done something weird to the quotes, to like the so-called smart quotes. Red. Well, all right. Had we gotten that, you would have found, for example, District 9 in Pan Am is listed here, which is not a country nor a continent. There's a negative life expectancy in here somewhere. A GDP that's a little bit too low. Anyways, that's a start. What do you think?
This looks like all the bits and pieces for a testing framework. So are there testing? There must be. The answer must be yes. So what is the testing framework in R that uses this stuff? What's it look like?
This is all too new, I think. There is there's tests.
Yeah.
You could do tests for functions and have like your test coverage in Travis. Is that what you mean? That sort of continuous integration stuff?
You don't have to get that fancy, but sure, okay.
Yeah, true. There's absolutely no reason why you couldn't. So far as I know, testing in R is generally tied to like a package framework, right? So you could put your paper in a package, for example. And some people argue you should do this. And then you could have the tests that run, and part of it could be testing the data. Alternatively, you could, I guess you can set up any repository to build on Travis, right? And have anything that arbitrarily that runs. And it could run your test file on your data, and this could be part of the things that it tests. I don't know how to do that. Somebody would have to teach me. Yeah. Otherwise, I was thinking just in like a normal programmer's, normal data analyst's workflow, you'd have an R script that would run one of these dplyr pipelines, one of these pipelines like this one right here. Run that for all of your data sets. You would name that function and you would call it on all your data when you get it. So that would work nicely with you've got a bunch of R scripts that define functions and one major script that runs them all. That's how I think most R users work. And that would be convenient.
That would work well in like a make pipeline.
It would be fantastic in that context. You could put this into an R script that would accept an argument and that you could have make run it on all of your data sets. That would be another excellent option. One thing I think they're making, or is possible to do, is to configure it so it warns, doesn't error, because sometimes you just want to know if there's something weird that's happening. You don't want to actually stop the whole train just because somebody forgot a decimal place or something.
No. Warnings are too easy to ignore.
You like the error.
Yeah.
All right. So that's that. Here's my.
Cool.
Was that? Yeah.
Yeah. Thanks, Andrew.
Thank you guys very much for coming. Any other ideas about how this could be a better? I'm actually planning on giving this lesson in 2 weeks' time to graduate students in this very room. So
the Easter egg hunt idea is super cool.
okay.
We just have to figure out how to load it. Although, like,
It's
I don't
silly.
want to. What's it?
That was silly.
Yeah, I don't know. I mean, also, like, I don't want to be too harsh. It could just be my fairly feeble R skills.
No, I think it was my fault for making it with quotes in it. It read in. I was like, it reads in fine, but it reads in incorrectly. Ah well.
But yeah, once that's sorted, then that's something small. That'll be a great exercise.
Mm-hmm.
It'll be really cool.
What's your solution?
Well, this is only slightly less new to me as it is to you guys. So here's my possible solution. Floor rounds the number down. So if a number has a decimal place, it seems to me, its value minus its value rounded down must be greater than 0. So that will return true only if, I mean, maybe that's not the right way to test because of floating point weirdness. I don't know, but has no decimal should be true. For example, has no decimal 6, true. 1, false. So this would hopefully throw errors in an asserter pipeline if somebody entered a decimal place, life history, or whatever, population size or something.
Mm-hmm.
I'm also excited about this. I wanted to solve this purely mercenary. This is another problem we get a lot in ecology, where you have counts of things, for example, that are sometimes right next to masses or lengths of things. And it's very easy for somebody who's typing the data in to just not hit tab and put the wrong number in the wrong cell. And this is an easy peasy way to find it. Where a histogram might fail to find it. It's perfectly possible for you to have 27 insects and also 27 grams of leaves in the same plant. So, yeah. All right. Thank you guys very much.
Thank you. Good stuff.
Thank you, Internet. Bye for now.